The sun, a blazing sphere of immense energy and power. It's a giant ball of plasma constantly in motion with its surface roiling and churning. It's the center of our solar system, holding all the planets, including Earth, in its gravitational embrace. And it's the source of all life on Earth. The sunlight that filters through the leaves, the warmth that we feel on our skin, all come from this magnificent star. Without the sun, our planet would be a frozen wasteland, devoid of life, a stark and barren landscape. The sun provides us with light, warmth, and energy. It powers the cycles of nature, from the water cycle to photosynthesis in plants. But the sun is also a powerful force of nature. Its surface is a cauldron of activity, with solar flares and sunspots. It can unleash bursts of energy that can disrupt our technology and way of life, causing solar storms that affect satellites and power grids. The sun's energy comes from nuclear fusion, a process that powers the stars. This is the process of combining atoms to create energy, specifically hydrogen atoms fusing into helium. The sun is constantly fusing hydrogen atoms into helium, a reaction that releases an enormous amount of energy. This process releases a tremendous amount of energy in the form of light and heat, which radiates out into space. The sun's energy travels to Earth in the form of electromagnetic radiation, a spectrum of energy that includes more than just visible light. This radiation includes visible light, ultraviolet radiation, and X-rays, each playing a crucial role in our environment and technology. The sun doesn't always shine with the same intensity. It goes through cycles of activity. These cycles are known as solar cycles. Each solar cycle lasts about 11 years. During a solar cycle, the sun's activity waxes and wanes. At the peak of a solar cycle, the sun is at its most active. This is known as solar maximum. During solar maximum, the sun produces more sunspots, solar flares, and coronal mass ejections. These events can release huge amounts of energy into space. Some of this energy can reach Earth and cause problems. Scientists predict that the next solar maximum will occur in 2025. This means that we can expect to see an increase in solar activity in the coming years. It's important to understand the risks associated with solar maximum. We need to be prepared for the potential impacts. One of the biggest risks associated with solar maximum is the potential for internet outages. Solar storms can disrupt the signals that carry internet traffic. This could lead to widespread outages that could last for weeks or even months. Imagine a world without internet. Sunspots are cooler, darker areas on the sun's surface. They are caused by intense magnetic activity. Solar flares are sudden bursts of energy that erupt from sunspots. Coronal mass ejections, or CMEs, are massive eruptions of plasma and magnetic field from the sun's corona. CMEs can travel at speeds of millions of miles per hour. These solar events can have a significant impact on Earth. Solar flares can disrupt radio communications and GPS systems. CMEs can cause geomagnetic storms. These storms can disrupt power grids, damage satellites, and even pose a radiation hazard to astronauts. Section 5. Solar storms when the sun unleashes its fury. Solar storms are a serious threat to our technological infrastructure. A severe solar storm could have devastating consequences. It could knock out power grids, disrupt communication systems, and cripple our economy. Scientists at NASA and other space agencies are constantly monitoring the sun for signs of solar activity. They use a variety of instruments to track sunspots, solar flares, and CMEs. This information allows them to provide early warnings of potential solar storms. However, even with advanced warning, there is only so much we can do to protect ourselves from the sun's fury. Section 6. The Carrington Event, a stark reminder of solar power. In 1859, the largest solar storm ever recorded struck Earth. This monumental event was a wake-up call to the power and unpredictability of our sun. This event is known as the Carrington Event, named after the British astronomer Richard Carrington, who first observed the solar flare. The Carrington Event caused telegraph systems around the world to fail. Telegraph lines sparked and caught fire, and the entire communication network of the time was thrown into chaos. Some telegraph operators even received electric shocks from their equipment. The intensity of the storm was such that telegraph paper caught fire, and operators were left bewildered and injured. The aurora borealis, also known as the Northern Lights, was visible as far south as Cuba and Hawaii. This spectacular display of lights was both beautiful and eerie, a testament to the storm's power. If a solar storm of that magnitude were to occur today, the consequences would be far more severe. Our interconnected world would face unprecedented challenges. Our modern society is heavily reliant on electricity and technology. From smartphones to data centers, our daily lives depend on a stable and continuous power supply. A Carrington-level event could cause widespread blackouts, disrupt communication systems, and damage critical infrastructure. Power plants could be rendered inoperative, and the internet, which is the backbone of modern communication, could be severely affected. Emergency services would be overwhelmed, and communities would need to come together to cope with the aftermath. The resilience of our society would be put to the test. Scientists are continuously studying solar activity to better predict and prepare for such events. Advanced telescopes and satellites monitor the sun's behavior, providing crucial data to help mitigate potential impacts. Public awareness and preparedness are key. Educational programs and community drills can help ensure that we are ready to face the challenges posed by solar storms. By understanding the past, we can better prepare for the future. Section 7. The Internet's vulnerability, a modern concern. The Internet is a complex and interconnected system, a marvel of modern engineering that connects billions of devices and people around the globe. It has become an essential part of our daily lives, enabling communication, commerce, and access to information at unprecedented levels. However, this intricate web of connectivity is not without its weaknesses. It is vulnerable to disruptions from a variety of sources, including natural phenomena such as solar storms. These storms, caused by eruptions on the sun's surface, can send massive bursts of energy towards Earth. One of the critical components of the Internet's infrastructure is the network of undersea cables that transmit data across continents. These cables, stretching thousands of miles along the ocean floor, are the backbone of global Internet connectivity. Unfortunately, these undersea cables are particularly vulnerable to the effects of geomagnetic storms. When solar storms interact with Earth's magnetic field, they can induce electric currents in these cables. A strong geomagnetic storm could induce electric currents in these cables, causing them to overload and fail. This could lead to significant disruptions in Internet service, as the cables are critical for maintaining the flow of data between continents. The consequences of such an event could be severe. Widespread Internet outages could last for weeks or even months, affecting everything from personal communication to business operations and emergency services. The impact on society would be profound, highlighting our dependence on this technology. In addition to undersea cables, solar storms can also damage the satellites that provide Internet connectivity to remote areas. These satellites are crucial for delivering Internet access to regions where traditional infrastructure is not feasible. Damage to these satellites could further exacerbate the disruption, leaving remote communities without vital communication links. Section 8. Satellites at risk disruptions in communication and navigation. Satellites are essential for a wide range of applications, including communication, navigation, and Earth observation. However, they are also highly vulnerable to the effects of space weather. Solar storms can damage satellite electronics, disrupt their orbits, and even cause them to re-enter the Earth's atmosphere prematurely. The loss of even a single satellite could have significant consequences. For example, GPS satellites are used for everything from navigation to financial transactions. A disruption to GPS services could cripple transportation systems, disrupt financial markets, and even pose a risk to national security. Section 9. The Hydro-Quebec Blackout, a cautionary tale. In 1989, a powerful geomagnetic storm caused a major blackout in Quebec, Canada. The storm caused the Hydro-Quebec power grid to collapse, leaving millions of people without electricity for hours. The blackout is a stark reminder of the potential for solar storms to disrupt our lives. While the Hydro-Quebec blackout was a relatively localized event, it highlighted the vulnerability of our power grids to solar storms. A larger storm could have much wider-ranging impacts, potentially causing blackouts across entire continents. Section 10. Preparing for the storm mitigation and resilience. So, what can we do to prepare for the next solar maximum? There are a number of steps we can take to mitigate the risks and increase our resilience to solar storms. These include hardening our power grids, developing backup communication systems, and improving our space weather forecasting capabilities. By taking these steps, we can reduce the impact of solar storms and ensure that our society is better prepared for the next time the sun unleashes its fury. Section 11. Conclusion. Respecting the sun's power. The sun is a powerful force of nature. It gives us life, but it can also pose a threat to our technological civilization. As we approach the next solar maximum, it is more important than ever to understand the risks of solar storms and to take steps to protect ourselves. By respecting the sun's power and preparing for its wrath, we can ensure that our society continues to thrive in the face